we're just going to talk about specifically how water changed and how the perception of water changed over that time period. Because ultra-pure water has become a tool, a really incredibly valuable tool to the semiconductor industry. And
Well, the television tube industry also.
and the television tube industry also. And it is, we could not do the things that we're doing. We couldn't have sent the astronauts into space. We could not have CDs. We could not have this recorder, our cell phones, without the miniaturization that was made possible by this incredible water that I think Mr. Chase here was very very much a part of, and Austin McCormick were very much a part of. So
Two key guys. You realize that, Ed?
incredibly, and I feel lucky to be here, and that the story is coming out.
It took us 50 years to realize it.
The problem, I think, without them realizing it, was that you guys made it look too easy. It was available when they needed it.
Well, to us,
What's this
it's
really
just
cool
a
water?
problem. We solved the problem. Went on to the next problem.
Okay, so let's hear about Mr. Chase and his career. How did you get involved? How did you ever think of that you getting involved in water purification?
Well, I was, give you a little bit of my background. I grew up on a farm in Iowa, and I lived through the Depression years, which were very difficult
Miserable.
times. And I went to college. I had to go where I could work my way through. My folks scrounged up about $50 for me to go off to college. And I found a college in northwestern Missouri, which had a good reputation, which has been defunct now for a number of years. And I could work there the year round. So I started the college in 1940, fall of 1940. I had planned to go there for perhaps 2 years and then go to Iowa State at Ames, Iowa, which is Iowa State University, for engineering. At that time, I knew I wanted to be an engineer, but I didn't know what particular one.
Yeah, right.
So the 2 years went by and the war came on in the early 40s. And about my middle of my junior year, I joined the Air Force Reserves because I had two uncles who were Air Force, three uncles who were actually Air Force officers, two of them pilots, and that's what I wanted to do. So I joined the reserves hoping to finish my junior year before we got called up. Well, later on in the fall then of 42, we got called up, everybody. And I was fortunate to have enough good health and eyesight to be accepted as a pilot training. So I went through all the different pilot trainings that you go through, which takes a long time, and ended up as a B-17 bomber, four-engine bomber pilot. And you're probably familiar with the B-17, I suppose most people are. And I was assigned to the 8th Air Force in England. I flew a new plane from Lincoln, Nebraska, over the northern route to Valley, Wales. I had 30 missions over Germany in the latter part of the war.
Wow.
Jeez.
I came back with a war-weary plane and flew the same route back with my crew, ground crew, and a few tech officers. And I considered actually being a commercial pilot, which I like to fly. Well, pilots were a dime a dozen at that point,
Sure.
and the commercial air had not been, they were just getting started after the war.
Right.
So there was no place for me, so I figured the best thing for me to do was to go back to college and finish my degree. So in the meantime, I got married, and both my wife and I went back. I had planned to go directly to Iowa State, but when I stopped by after I'd been discharged from the service at the college in Missouri, and the dean said, well, we can give you some credits for what the training you had, because we had college credit courses actually in Air Force training.
Sure.
I was at James Millikan University for a time in training, and James Millikan in Illinois. It was across from St. Louis. And so we went, they said, well, if you come back, I didn't get out of service till too late to start the fall term. So he said, if you come back the second term and take a course in the summer, we can get you a liberal arts degree with majors in chemistry and math. And after thinking it over, I decided that was too short a time to throw away, to speak, a liberal arts degree. So I went back, both my wife and I, to college, and we stayed there, and I finished my degree. I then planned to go to Iowa State immediately. I couldn't find any place to live. The housing was just impossible for my wife and I. The GIs were coming in like flies to college.
Yeah.
The president of the college wanted me to teach, and which I finally decided to. My wife then was the secretary of the president of the college, so we were doing reasonably well. And so we stayed a year, and I taught algebra, trigonometry, and chemistry lab and physics lab for a year. Then we went to Iowa State, lived in an old War trailer.
You had some money then.
Yeah. And which was we could get after having our name on the list for a year. So we finished a degree in chemical engineering at Iowa State in the spring of '49.
Okay.
And I was hired on by Sylvania. I had done a course in my senior project had to do with, if I remember correctly, with recovery of copper, and we were using ion exchange
Synthetic?
to remove the copper.
Using styrene resin, or was it green sand?
Well, it wasn't. It was actually cation resin
Okay.
to remove the copper. I'm pretty sure, because I think I
That
had
would remove
contacted
copper.
IWT at that time to get some resin to work with, and that's, I think, is where I got tied up with IWT. And I think that helped because a Dr. Bowie, who ran the Bayside Laboratories at that time for Sylvania, hired me on, and they really didn't, at that time, the black and white television picture business was just in the infancy.
Just starting in 1950, yeah.
In 1949, actually 1949, because I started to work April 4th of 1949 in Emporia, Pennsylvania.
Okay.
And there were so many problems. The tubes were black and white were being built essentially by hand, and of course water became one of the major problems. And so I just Sylvania was great in that respect because you could kind of make your own path. If there was a problem and you jumped on it and were interested in it, that was fine. And that's what I did, and that's where I really got started with the demineralization of water.
Right.
Because at that time, they were using stills, and of course that quality is not all that great, and you're still having problems. See, the black and white TV, I don't know if you're familiar with it or not, but it's a settling process where you have a potassium silicate gel. You have to work all through the bottle, so to speak. Everything goes through the neck of the bottle. You put in potassium silicate, you have to have a gelling agent, and the phosphor goes in and then settles through the liquid. And on the face, then a gel forms which attaches to the glass, and then you have to gently pour this off, the liquid off, after it settles, the phosphor settles out. There are two different phosphors that you used, and if there's anything affected the gelling or the adherence to the glass, you get rejects. You'd have
Right.
tracks and
Right.
bubbles and things like that. So organics were one of the big things we were concerned about, because there are certain organics which was never fully identified that cause little tiny pinpoint bubbles. And these, when you try to pour it off, these form tracks and make a reject. You also need good quality water, because there are certain things like copper and iron. Copper will shift the color of the phosphor. It diffuses into the crystal of the phosphor and shifts the color.
Makes it a little green.
Mm-hmm. And iron, for example, will diffuse in and deaden the phosphor, so that you don't get the light output that you're supposed to have. So those are the primary things, I guess.
What size tubes were those?
Well, we were talking originally as little as 3 inch, and then they kept getting bigger and bigger and
Yeah.
bigger and bigger. And there were times when the water wasn't right, you'd run 100% scrap. You were putting out anything. I was called to, I've been several times down to the plant we had in Venezuela. They were completely shut down, and also in Monterrey, Mexico. And I'd have to get on the plane and take off and fix the problem. And they wouldn't let me out of the course until I had the problem fixed. But sometimes, they get the resin fouled up. They weren't pre-treating properly, they weren't regenerating properly, and all these things. But if you went through did you read the
Full
these
page,
articles?
yes. We went through the full page.
Well, we kind of developed the treatment kind of depended upon the source of the water and what was in it.
Right.
We could get by with deep well water with the minimum pre-treatment,
Right.
usually just some filtration. But as you get into more and more, and some surface supplies, now Cuba Lake wasn't too bad. It's a deep lake, and this wasn't too bad. We after the fact, we put in the system with just retention time and chlorination and alum in a settling tank and
But
a
you
pressure
only had,
tank.
You only had
so
1 hour of settling, is that right?
You
Yeah.
said alum?
alum, yeah.
Alum, okay.
For our purposes, alum seemed to be the best for removal of organic content. And that's what we didn't use in any of whether it was a retention tank or the clarifier, we used alum exclusively for that purpose. And so we kind of tailored the pre-treatment and the system to the quality of the water that we had to work with.
Sure.
I
We
think
tried to work when we built the Fulton, California plant. Their water source, of course, was the Colorado River water, which is pumped 230 odd miles from the Colorado River over through a lot of different reservoirs and what have you, to the LA treatment plant. And I've been through all that system and on my travels to Fullerton. We tried to use that, and there was so much organic content in that stuff, with the high temperatures and river water and all of that, that we were going to have to put in a clarifier. In fact, I had started to design a system with a clarifier, but our management decided that they would rather not take a chance. I said, I'm sure I can do it with a clarifier. But they said, no, we're going to go to the LA County or whatever it is and get the permission to, he had to do this, to drill a well out there in that area. You can't just go drill a well, you got to get a permit to do it.
Yeah.
So instead of putting the clarifier in the pretreatment system out there, they elected to go with the drill a well and use.
With your own well water?
Yeah.
Yeah, so that was, that's sourcing your water. You're determining
Mm-hmm.
what water to work with.
Mm-hmm.
I'd like to ask you more on that. Do you remember what sources of water you had for each facility?
Well, I think that this is, at least some of them were listed in this
Yes, that's
article here.
4 different plants, right?
Yeah, the 4 that are listed here. Of course, we had a lot of, later on we had a lot of other plants as well. But these, I think,
Bolton was in there.
yeah, there was
Cuyahoga something.
mixed bed, laboratory control.
Plants are listed.
Yeah, there was, no, this is,
We can go back to that at another time.
somewhere I mentioned that there was, of course, Seneca Falls and Ottawa and Hatboro, Pennsylvania, and I think Fullerton. I believe there were 4 plants that we mentioned here.
So you abandoned the river water at Fullerton.
Yes, I say I had already had started to design a system for the Fullerton plant, but the management didn't want to take a chance. They decided they'd rather go with the deep well water.
Yeah, that was
That's
a good
a
decision.
good choice.
The Ottawa had deep wells initially. Later on, when the water requirements got higher and higher, because Ottawa is a real small community, and had an awful lot of sulfur, high mineral content water, and eventually they had to pump water from the river, and so we had to kind of change our system accordingly. But basically that became the pattern. If you had deep well water, you could get by with minimum pretreatment. And beyond that is in the different surface waters, you tailor what you have to do to the quality of the water. However, in the later plants and also the semiconductor plant up at Hillsborough, New Hampshire, we started right off with clarifier up there as well, using alum.
Is that a Bermuda unit? Was that
I
a
don't
Spalding?
recognize that plant.
I had opened some of these up. I didn't know whether you'd have any interest in that or not, but the Bayside Labs back in the early time here were doing research work on germanium.
Mm-hmm. I did read that.
Did you
Uranium
read
and
that?
silicon. That's very interesting.
The problem with Sylvania basically was they did a lot of wonderful research in their labs, but they didn't know and couldn't adapt well, which I think was due to lack of chemical engineering versus chemist mentality of how to scale up to a production facility.
Mm-hmm.
Yeah.
Because I don't remember whether I was with you at Woburn or not, but I do remember being in Woburn, and what I remember
I
was
got the order from you for Woburn.
okay. What I remember was when I visited there, the first, and I think I don't know, I must have gone back, but the first time I was there, they had the pilot lines that they were running. It was just all they'd done is just put more and more laboratory pilot lines in parallel. And they had one fellow who did nothing but change mixed bed cartridges. on the end of the line.
Nothing
So
but
I
change.
at least, and I don't remember all the details of this, but that's the reason we ended up. I convinced them to go to a central system. And my mind's very fuzzy as to how we got that equipment in there. I did all of my work in all of the plants, regardless whether it was overseas or all the way across this country. All of the systems were designed in conjunction with Vince Miller, who was a chemical engineer and probably the primary sales rep for IWT.
Yeah, I knew him.
Didn't you know? Yeah.
Yeah.
He was a great guy and very, he was a sharp fellow and,
He was a tough competitor.
right. And I say, regardless, I worked the Venezuela, the Monterrey, Mexico, and we actually, I was involved with the international division because they would come back to me. I was really utilized across the whole company for water and water treatment.
Great.
And we designed a number of plants, most of which were not built, some for Czechoslovakia, and I've forgotten some of the others. They did build one of the plants in Algeria, which was an interesting one because they had nothing but deep, deep well water with mineral content that I think you pump it out on the ground, you could probably walk on.
Right.
But as I remember there, I think we had everything from clarification to two beds and filtration, of course, and two beds. And we may have even had reverse osmosis in there someplace, I don't know. We ended up, of course, with mixed beds. But this was kind of an all electronics. They were going to make everything from picture tubes to all the various and sundry kinds of electronic devices.
Yeah.
And they did build that plant. As far as I know, it operated satisfactorily. I don't know. I never got over there. But we had a lot of interesting situations to cover.
What happened down in Brazil?
They had a clarifier down there and a black and white TV tube, yeah.
I provided a clarifier for
Yeah.
Brazil,
Okay,
but they had a manufacturing plant down there.
that's right. Yeah, our people went down. That's one place I didn't get to, but our people out of Seneca Falls actually ran the plant, operated the plant. They moved them down there.
Okay.
And they were, as far as I know, they got along okay. At least they were producing tubes anyway.
That was a surface supply, or what was that?
With clarifier, likely.
Yeah, I'm sure there was a clarifier. I would suspect, I don't honestly know. I don't honestly remember what they had.
You want to take a break? Take a break?
Anyway, you bought the whole thing from me.
Mm-hmm.
I think clarifier, filters, carbon, dynamics, that.
Do you know what did they use alum or?
Sure, yeah,
Okay.
This is a Spalding clarifier?
yes.
This is a Spalding clarifier?
Absolutely, yeah.
Spalding precipitator, upflow precipitator, right?
That's correct.
Okay.
Spalding had the advantage, the separation zone was built like that. And the water came in here as fine particles. And as they worked their way through this mess, sludge, they got to be larger size. So, and this zone here might be 10 foot high. So to go all the way up there like that, and the upflow velocity kept getting lower and lower and lower and lower. So they finally found some spot where they were comfortable. And then everything else would have to bump into that and become enlarged. So that separation zone was very important. You had to grow the particles.
Well, I think we gradually learned our lesson too, that, clarification was the proper way to go with any kind of
It's the only way
surface
to
source,
make
yeah.
little particles and the big ones.
Yeah.
Now, the big ones float, you know,
Yeah.
and in a 2-inch zone,
Mhm.
you can go from 2,000 parts per million here, and 2 inches higher, it'll be 2.
Mhm.
It's a fantastic separation, right at the level of the blanket.
We had clarifiers on our wastewater treatment, both,
Yeah.
I don't know whether you provided those or not. In Ottawa, we had a big clarifier, and in Seneca Falls as well, in the waste treatment system.
I don't remember.
I don't remember either.
I left Dallas in
Mhm.
'58, and ended up I left Rochester in '58. I went to New York for a while. Then I was assigned to Dallas, and when Texas Instruments was just getting ready to explode, and they had the same problem that we had at Woburn.
Did you ever run into Walter Zaban, Chester Engineers?
Chester Engineers, no, I did not.
Okay, he did most of our consulting work as far as wastewater treatment is
Wastewater,
concerned,
okay.
yeah. And the last one we put in at Ottawa, Ohio, the one in Seneca Falls was not automated, but they put it, later when we put in Ottawa, Ohio, was fully automated with computerized. So after about, after about the mid-60s and certainly 70s, we had, at least, I guess we thought we knew how to handle most of the water for process was concerned. And I had to concentrate on wastewater plant effluent treatment because the regulatory people were bearing down on us.